A common misconception held amongst consumers is that the internet is invisible and that it lacks physical characteristics. For decades, fiber optic cables have acted as the backbone of the global internet, facilitating high-speed data transmissions between continents. The physical digital infrastructure can be found at the bottom of ocean floors. They consist of tiny optical fibers armored in steel and insulated with polyethylene, ensuring lengthy structural integrity while operating even in the harshest conditions. Orange Marine is a major French player in the laying of new submarine communications cables and maintenance of already existing cables across the Atlantic, Indian, and Pacific Oceans, representing around 15% of the world's fleet. With their 100 years of experience and 7 substantial operating ships, they have installed nearly 300,000 kilometers of cables and performed almost 1,200 repairs. Active since the mid-19th century, the submarine cable branch of the French Ministry of Posts and Telecommunications became wholly owned by the Orange Group in 1999. A little later, they acquired CIMEC Technologies, sparking new innovations in crucial cable ship technologies, and created the Chamarel Marine Services. Currently led by CEO Didier Dillard and Engineering Director Geoffrey de Dinachan, Orange Marine continues offering its services, ensuring a high-quality global network available to us all. Orange Marine is a company voluntarily committed to controlling and improving their environmental footprint. They continuously monitor their activities to determine how they can modify their operating procedures to become a greener company. Their objectives include reducing energy consumption and their impact on the environment and global resources. Additionally, they make a strong effort to control the risk of accidents and pollution related to the company's operations. They demonstrate this effort through their innovative work in energy-efficient ships that limit toxic emissions and other environmentally threatening aspects that affect both land and sea. This is most evident in the Sophie Germain, launched in 2023. Named after the French mathematician and physicist, this is the first cable ship of its generation specially designed for maintaining fiber optic communication cables and inter-array power cables used in offshore wind farms. The vessel's streamlined hull and engines are designed to reduce fuel consumption 25% lower than the average cable ship. Additionally, she is powered by a network of solar panels when berthed, reducing her carbon emissions. Ultimately, the Sophie Germain's overall design has resulted in 22% fewer carbon dioxide emissions, 82% fewer nitrogen oxide emissions, and a clean ship classification and waste management, highlighting the care Orange Marine has put back into the environment. When we communicate using digital devices, the information goes through multiple interconnected telecommunication service networks before reaching the intended recipient. This process works by connecting 2 or more onshore terminal stations or cable landing stations with a fiber optic cable. These cable landing systems contain submarine line terminal equipment that enables the transmission and reception of signals. The terminals receive signals from undersea cables and then transmit the signals inland to terrestrial networks, usually through a provider's point of presence or interconnection facility. The subsea cables themselves are fiber optic cables that are thin, flexible, and transparent glass, or sometimes plastic strands that allow signals to be sent over long distances using pulses of light rather than electricity. The process of sending messages through pulses of colored light signals of various wavelengths is a technique known as wavelength division multiplexing. Most subsea cables function by transmitting in one direction on one fiber in the core and transmitting in the reverse direction on the other fiber. As signals pass from one segment of an undersea telecommunication cable to the other, repeaters boost the signal with optical amplifiers by employing semiconductor laser pumps, allowing the signals to travel long distances, using optical equalizers to maintain integrity. Over 95% of international internet traffic runs through submarine cables, but who controls this hidden infrastructure? Companies like Orange Marine, a French operator, install and maintain these cables, but they rarely own them. Ownership lies with tech giants and private telecoms. So what happens when a cable lands in your country but belongs to someone else? Your nation becomes dependent on foreign infrastructure for its data, and with that comes risk, surveillance, coercion, control. At sea, there's no global law to protect data. In international waters, anyone with a deep sea sub and enough funding can tap your internet. Documents leaked by Edward Snowden showed how the NSA and its allies intercept data directly from cables. GCHQ even had real-time access to entire networks. This isn't about your browsing history, it's about national sovereignty. If a US-based company owns a cable connecting West Africa to Europe and the cable lands in Senegal, US intelligence could still legally access that traffic through American servers or secret surveillance programs. And while the US demands transparency from foreign networks, it continues to build a global surveillance architecture it won't let anyone audit. So the question isn't who laid the cable, it's who can see your data when it passes through it. And too often the answer is not your country, not your laws, but someone else entirely.